This lesson is about graphing exponential functions. This is an exponential function. What makes it exponential, we have a variable that's an exponent. Usually we see polynomials and the variable is right next to the number or coefficient. But here, the variable is where the squared or the cube term is, and it's an exponent, we call it an exponential function. So when actually graphing it, it's best to come up with a table of values. I will come up with a table of values. I'm going to pick two numbers to plug in for x, 0 and 1. I like those two. Those are two pretty easy numbers, and they're pretty close to the origin. So when I actually graph this, I need to figure out the outputs if I plug in 0 and 1 for x. So I take the equation, y equals 3 to the x, and I'll first plug in 0 for x. So y equals 3 to the 0 gives you 1. So output at 0 is 1. Then, after I do that one, and take that equation again, y equals 3 to the x. I'm going to replace the x this time with 1. So y equals 3 to the first. So that's just 3. So when the input is 1, output is 3. These two represent ordered pairs. That's the ordered pair 0, 1. That's the ordered pair 1, 3. So when I plot these points on my graph, to graph it, one ordered pair is at 0, 1. And one is at 1, 3. 0, 1 would be here. And 1, 3 would be over 1 and up 3. So those are the 2 points. And now in order to graph it, keep in mind, in this function here, you don't have a number being added to it. So that number is plus 0. The number here being added to it is my horizontal asymptote. Horizontal asymptote. Horizontal asymptote is a line this graph would approach forever but never actually cross. The horizontal asymptote is going to be a horizontal line this graph didn't actually cross. This horizontal line is when y equals 0. So the horizontal line when y equals 0 is right here, which is basically the x-axis. So in this problem, the horizontal asymptote is the x-axis. So to finish graphing it, I'm going to start on my asymptote. I'm going to go through those 2 points. And the graph doesn't actually touch the asymptote, it just approaches it forever. I generally just kind of start there because it gets so close, it almost becomes that number, which is 0. So that's the graph of the first one. I'll give it a new one. The directions here say graph this function. We'll still start off by coming up with my table, is x and y. Ordinarily, I make my table 0 and 1 for x. But in this problem, since I started off with a number that's in the exponent is not just x, I need to figure out what makes this exponent 0 and 1. So I'm going to plug in x plus 1 equals to 0. And I'm going to take x plus 1 and I'm going to set it equal to 1. I want to figure out what makes this exponent 0 and 1. So I can figure out what number to plug in for x. So when I take my first one, I'll subtract 1 from both sides, and I'll get x equals to negative 1. So negative 1 is the first number I want to plug in for x. In my second one, if I subtract 1 from both sides, I got x equals to 0. So 0 is the second number I'm going to plug in for x. So this time, I'm going to plug in negative 1 and 0. So taking that equation, I will write y equals 3 to the x plus 1 plus 2. And we'll replace the x with negative 1 this time. And y equals 3 to the negative 1 plus 1. Plus 2. 3 to the negative 1 plus 1 is 3 to the 0. Plus 2. We should know the any number to the 0 is 1. So it means 1 plus 2, which is 3. So when I input negative 1, my output is 3. Then taking the second number 0, going back to that equation, 3x plus 1 plus 2. If I plug in 0 for x, I should get 3 to the 0 plus 1 plus 2. 0 plus 1 gives you 1. So 3 to the first plus 2 is just 3 plus 2, which is 5. So when I input 0, the output is 5. Now I got 2 ordered pairs. If I actually plot those 2 ordered pairs, one point is going to be at negative 1, 3, so we plot that number. It's going to be at -1, +3. The other point will be at 0, 5. So let me make this go up a little higher. This would be 5. So 0, 5 would be this point. Now, find my horizontal asymptote. In this case, my horizontal asymptote's here. This is my horizontal asymptote. And it's 2. So at 2, I'm going to make a horizontal line. So if I go through those two, if I solve my asymptote and go through those points, this will be the graph. It flattens out on this side and it goes up to those 2 points. And that's it. That's how you graph it. I'll give you another one though. Alright, here's a new one. It says graph this function. So we can start with the same thing. We'll start with the table of values. The only time you have to set this part equal to 0 is if you have some number being added to the exponent. You don't have any numbers being added to the exponent, like in the previous example. So now I can just set my x values to be 0 and 1. So taking that function, which is y equals to 1/2 to the x, take away 3, I'll plug in 1/2 to the 0, take away 3. So this is 1 take away 3. So it's -2. So my first output is -2. Then taking the same function, so it's 1/2 to the x take away 3. So it's 1/2 to the first take away 3, which means 1/2 subtract 3. You plug it into the calculator, you should get 2.5, or -2.5. So my second output is -2.5. I still have a horizontal asymptote here, which is -3. So when I graph it, I can plot these points. One point is 0, -2. So 0, -2 is here. Other point is 1 and -2.5. So we'll go over 1, then down 2.5. It's about right there. Then my horizontal asymptote is 3. So here's my horizontal asymptote. Right there at 3. So to graph it, I need to start my horizontal asymptote and go backwards this way, up through those 2 points. This is called exponential decay. The reason why is this number in raised to the power is in between 0 and 1. Whenever you have that number in between 0, whenever this number is raised to the power is between 0 and 1, that graph represents decay. And decay generally looks like this. It's a graph that goes downwards as it goes to the x-axis and approaches the asymptote. Let's give it another example. Last one is this one. So here, that y equals 2 to the x plus 3, take away 5. So now, when I come to my table, I can't just use 0 and 1 this time, because now I got to figure out what makes this exponent 0 and 1. So I'm going to take that exponent, x plus 3, set it equal to 0. Then I'm going to take that same exponent, I'll put it over here, x plus 3 equals to 1. When we solve this for x, you should get, subtract 3 from both sides, and this is -3. So that's a 3. So for one value, I'm plugging for x is -3. The other one, I subtract 3 from both sides, I get -2. So after I get those two values of x, I should then take these values of x and plug it back into that function. So taking that function, which says y equals to 2 to the x plus 3, take away 5. When I plug in -3, it becomes 2 to the -3 plus 3, take away 5. It gives you 2 to the 0, take away 5. 2 to the 0 is 1. So it's 1 take away 5, which is -4. So at -3, the output is -4. And then from there, we take the -2. So taking the same function, y equals 2 to the x plus 3, take away 5. I'll write it as 2 raised to the -2 plus 3, take away 5. So it gives you 2 to the first, take away 5. That's 2 subtract 5, which is -3. So at -2, my output is -3. So we're going to graph this. my 2 points are -3, -4. So I'm going to go over to the left 3. This is at -3. And go down to -4, which is here. The other one's at -2, -3. So go to the left 2. And go down to -3, which is about there. So those are 2 points. My horizontal asymptote here is -5. So draw a horizontal line through -5. And to draw it, I'm going to start on my asymptote and go up through those points. Then it bends upwards, almost straight. So that'll be the graph for that function. That's all I have. Good luck.